Studying theoretical physics prepared our next speaker for complex problems, and his hobby for juggling 5 balls helps him multitask between debugging and coffee spills. That's pretty impressive. Please welcome Max Bode with his talk title, How to Roll Your Own LLM.
Yeah, thanks for the nice intro. Sorry, I didn't bring any juggling balls. Hope you weren't expecting that. Yeah, I'm Max, flew in yesterday from Munich, Germany. Please excuse any jet lag you might be able to spot. And here's what I wanted to share with you today. Large language models are everywhere. And I wanted to recap some interesting use cases. And then in the second part, I wanted to talk why the heck anyone would not just use the available software as a service options you have for large language models, and share how we actually are running our own LLM infrastructure. And then I'd like to end with some hopefully interesting tidbits from our, let's say, research activities. Okay, everyone is using large language models. But here in this room, we have a special group of people, right? Software engineers. So why should we care in particular? I'd like to recall 3 ways to integrate LLMs into software engineering workflows. And the natural candidate to start this is AI-assisted coding. So how could I not start with mentioning that OpenAI told the world how important they think AI coding is by acquiring Windsurf, an AI-based IDE, for $3 billion, I think last week, right? And also another competitor in this space, Cursor, their evaluation is also through the roof. And there's this notion of developers being replaced by AI even. Let me make a slightly different prediction here. Developers won't be replaced by AI, but I think some developers will be replaced by other developers who learn to improve their workflows using AI, right? So an example, you might have heard of Ada, which is an open source CLI tool, which uses large language models to work on code. So how this works specifically is, this tool, you execute it in your repository, it gets an overview of your repository, builds something via a library called repo map, like an overview of which files there are, which files contain which part of the code. And then the workflow is you prompt your desired changes to the system, and Ada goes ahead, does LLM calls, requests, changes files for you, commits them, and hopefully you review them afterwards. And this graph shows a somewhat ironic statistic, being the more recent Ada releases have been mostly written by or with the help of Ada itself. So in my opinion, don't get me wrong, LLMs still have a lot of limitations that prevent them from building high quality systems like we would, right? On their own, at least. But I think it should be our imperative as software engineers to at least understand the space, understand what's out there, play around with everything to understand the limitations. And everything, I mean, this can be quite overwhelming because there's a new tool each week, right? So a somewhat, I hope, current landscape of available AI coding tools. On the left-hand side, you have these improved completion tools, basically, right? GitHub Copilot, you're probably aware. It works like code completion, but it not only can show you like which fields or methods does this object have, but rather also going from the semantic context, what might you be able to accomplish at where your cursor is currently located. And there are a lot of other tools in this space. Then these CLI-based tools like Ada, OpenAI and Anthropic have also released their variants now. Codex is even open source, I think. And so, by the way, are Continue and Klein and RuCode, recent fork. So a lot of open source activity also. Then the IDEs, right? Windsurf from this acquisition I mentioned, Cursor. These also can be used for something people are beginning to call vibe coding, where you just prompt and then go tap, tap, tap to just accept all changes and don't really look at it. I'm not saying I think that's a good way of working in every case, but it exists. And then on the right-hand side, there's these even maybe higher level of abstraction where you have just one prompt and then the site generators go ahead and one-shot whole applications. And this is also an interesting space. So let me make a second prediction here. Some developers might be replaced by product managers using AI tools to write code, right? And maybe these applications that are built there are not really super maintainable and production ready, but maybe they don't have to be like a POC or MVP. So yeah, it's an interesting space, and a lot of stuff is happening. And this was the more broad, let's say, LLM usage scenario for software engineers. I wanted to zoom in on 2 usage scenarios that are a bit more specific and narrow. And the first one is code migration. You might have seen this quote by, it's probably not readable, I'm zooming in a second, by Andy Jassy, president and CEO of Amazon. And here he's talking about using Amazon Q, which is their Gen AI assistant for software engineering, in the context of Java version upgrades. So here's the important part. He's saying that using this tooling has saved them the equivalent of 4,500 developer years. So all the people in this room working for quite some time, right? I cannot confirm this claim by own measurements with a similar order of magnitude, but what I can do is share what we have seen working well for different migration complexities. And what I mean by different migration complexities, you maybe have different setups, right? If the whole thing you're migrating just fits into an LLM context at once, and as you might be aware, context sizes have grown dramatically recently, you can just use an LLM directly and let it basically one-shot your migration. So think of you have maybe an existing small to medium bash script, few hundred lines, and you want that, I don't know, to be in Python instead, then you can just give that to, well, ChatGPT, and the result is probably acceptable. Then secondly, a bit more complex, you have a considerable code base, and then there are these, let's say, standard migration processes that are somewhat repeatable. So for example, as in the Amazon mentioned example, a Java version upgrade. Let me show you how we approach this second category. A good starting point actually is a non-LLM approach, but a rules-based approach. And open source software exists for that. Open Rewrite, for example, has so-called recipes to, I don't know, upgrade from Java 7 to 17. How do we actually apply those, or how do we use those in practice? It turns out these recipes are a good starting point, but they sometimes lead to code that doesn't actually compile. And we have built our reusable Java migration tooling around this, where we iteratively apply open rewrite recipes, and then, I don't know, compile via Maven the result. And then the error messages are piped into an LLM, and LLMs are quite good at this, right? They have compile error, then they can propose small patches to fix specifically this example. So you're missing this, catching this specific exception, something like that. And this migration is performed interactively by a developer, applying these recipes one by one and fixing the errors one by one. And this whole tooling can be configured to use different LLMs also, I mean commercial models, and then our internal models, which I'm talking about in a bit. And I can also show you code examples, just approach me. The third category here is even a bit more specific. And we found that custom tooling is required if the goal is to migrate between very, very different languages, different architectures, or if legacy languages are part of the migration. So such languages, think the COBOLs, Naturals, PLIs, languages nobody really wants to touch, no tooling is available, companies are not able to hire developers that can or want to deal with them. We've done some work in this area as well. Here's kind of an example. We've helped a large client from a German insurance industry, and they had this legacy PLI code around. So I'm not sure if you're aware, this is a language from the 60s, which happens to still be around, at least in German insurance. And in order to work with this, we needed to build a custom parser for that language. And we built IDE plugins, so in this case, JetBrains IntelliJ, to support the developers. And this whole project started with kind of a, I don't know, beauty contest with multiple companies at the beginning. And one was actually using a tool about which we heard an outlandish claim earlier, but we were the only ones who were allowed to continue. And the broad strokes of the approach look like this. So the source code is analyzed by this custom-built parser, and the results of this analysis are put into a knowledge graph, so graph database. And then this knowledge graph not only reflects the actual code, but also dependencies to other pieces of the code, because, I mean, that's, as you might imagine, that's important for the migration. And then for each migration step, LLM tooling pulls the code and information from the knowledge graph, translates it, and commits the translated code. And also already migrated code can be included in the knowledge graph. So dependencies on already translated code are taken into account. To sum up, these code migration efforts, basically completely automatic migrations only work for simple examples as of now. So as of now, experts still are important for analysis and review. And we found to be most successful the more iterative approaches, where only pieces of the code base are touched at one point in time. Yeah, and then it's probably a good idea to think about your test coverage while doing this. And so a nice complementary approach is using LLMs to generate test cases. That's the third use case I wanted to share. So the broad strokes of what we're doing here is, I mean, basically the natural thing to do, right? You prompt your system to generate tests from the repository context. These tests are executed, and you get kind of this feedback loop, right? The result of the test execution can be fed back into the LLM, and again, it can fix and correct. So more specifically, you break the problem down, right? So for one file, you go through all the methods to be tested and examine those. You create test scenarios, and for these scenarios, write the actual tests, assemble those into a suite. And the nice thing of breaking this down is that you can use specialized agents for different steps, right? So you might, for the planning step, a reasoning model might be more capable, but then for the actual writing of tests, you might use a cheaper model or one that is better at writing code. And people are liking Anthropic's Claude Sonnet, for example, when we're talking about commercial models. So some anecdotal results, again, from typical code bases we deal with, you can reach high coverage, starting from 0, basically. The results depend a lot on how testable the code is. That kind of makes sense, right? But the interesting thing is also that teams have told us, even if something goes wrong and you don't reach at, I don't know, 95%, the intermediate results are also useful or valuable to them because they might be a good starting point to write the test as a human. So this is a way to generate unit tests. Now, one additional idea, generating end-to-end tests. As you might be aware, LLMs nowadays can use so-called tools, and one of those tools are browser use. So basically, they can operate a browser and click on buttons and stuff like that, and you just instruct them by language. So our idea here was, can we just instruct an LLM to do a specific flow through an app, and then have this generated as an end-to-end test case that can then be reproducibly executed. And I mean, a natural candidate for doing these end-to-end tests, as you're probably aware, is Playwright, for example. And how this looks like, I'm not sure how readable this is. I hope somewhat. In this example now, the unit under test is a chat interface. It's something we use internally, like ChatGPT. It's called the TNG AI assistant. And we configure this test here to go to the lower text field and ask what is the capital of Cambodia, and then the answer contains the name Phnom Penh. Okay, so that's basically the whole test specification. And what now happens is the LLM uses a browser, tries to figure out the specific fields. Okay, it's somewhat fast. Here's the browser, and now you see weird colors. Here it's searching for buttons, and it's pasting something in the message field here, clicking on play, basically, and then asserts on the result that is somewhat readable here. And then what comes out of this is basically a Playwright test that you can then check into your code base, or can also adapt it, review it, of course, and then reproducibly execute the same thing against your code base, and this then happens quite fast, and you can't even follow anymore. So as a recap, AI-assisted coding is something you should look at. Code migration is an interesting niche for looking at LLMs, and test generation as well. And everything, all of those are based on large language models. So where do these large language models run? Usually not on your machine, right? You use ChatGPT.com, you use Claude, I don't know, Gemini, Vertex AI, Google, maybe even Mistral. There's something, oh, and I'm just noticing this is the German interface of ChatGPT, sorry about that. Yeah, Open Router is an interesting platform where you have multiple of these providers subsumed under one chat interface and API interface. So usually these run on someone else's machines. It is possible to run it on your machines, even this machine, right? This is not very beefy. It's a MacBook Air M2, 24 gigs unified RAM, but still, when I'm on a plane, which might or might not have Wi-Fi, I can use something called Ollama, for example, which I can recommend if you don't know it so far. It's quite user-friendly, to run somewhat capable models and talk to them. And this still feels very astonishing to me. But for beefier models, what do you need? Well, you need something like a data center. And this is what I'm talking about here. So we have begun looking into this. When I'm saying we, I'm referring to TNG. We are a consulting company, and we help our clients build software from startup to blue chip company. And specifically, the majority of our clients is from Europe, and many from regulated industries, telco, banking, insurance, and so on. And some of those are quite hesitant to make their data available to software as a service company in the US, or when we're talking DeepSeek, maybe even China. And I'm not even going into all of the complexity that is data exchange between Europe, America, privacy shield, data privacy framework, Schrems rulings. No, there is a demand for these like data sovereign solutions. Let's put it like this. How about supply? Well, we learned in Chris's keynote this morning why companies might be incentivized to publish OSS software, right? And this also applies to open weights models. And here are some of the notable sources of open models. Of course, it's incomplete. It's also Google, Microsoft, and others. But what's interesting here is which parts are actually open. And DeepSeek has been one of the first organizations that has also made public their training pipelines, which is very interesting to learn from. And none of the giants has also made public all of the training data. There are also approaches in this regards. The Allen Institute with Olmo models is something to look out for. But yeah, and very notable, OpenAI is not on this slide, right? And Sam Altman has called this being on the wrong side of history here. So we are looking forward to what might be published soonish. Let's see. Okay, but let's say you are convinced that you want to use LLMs in your workflows, and you might be curious on how to host those yourself. Okay, so were we? And actually, this was kind of a paradigm shift for us. We were in the middle of getting rid of all of our on-prem infrastructure that we historically had, and we're in a very, very nice world of infrastructure as a service. You just have your, I don't know, Terraform, CDK, definitions of all your software and your underlying infrastructure, and don't do any, I don't know, undifferentiated heavy lifting. But then came the GPUs, and we began a bit of heavy lifting. Again, I hope it's not so undifferentiated. And we invested in a bit of hardware, actually. So the base infrastructure here, some rack servers with connectivity, storage. You need to put all your weights anywhere. And then the interesting parts are actually down here. I mean, there is hardware you can use to experiment, like NVIDIA RTX 4090, 5090. But to really do this, to really run inference, fine-tuning loads, and so on, you basically need something like this, like H100 from NVIDIA. And we have those typically in 8 GPU nodes. So we have 2 of those nodes with the 80 gig variant of H100s. And then we have also one node with a bit more GPU RAM, 96 each. And this is interesting because it basically allows you to run models like DeepSeek R1 on one node without having to worry about node-node communication, which is really valuable. And then up until very recently, I guess NVIDIA has been the only real candidate to do this. It turns out that's maybe not the case anymore. We've been also looking at our options, like Intel Gaudi could also be interesting, but this hasn't proven to be attractive as of now. But basically, a few weeks or months ago, we wanted to acquire AMD machines, and last week they finally arrived. And this is also on the right-hand side. It's not really, you cannot really see it, but we now have a cluster with 8 MI325X nodes, and those have 256 gigs each. So basically, you get in this node a GPU RAM of 2 terabytes, which is interesting because you can do interesting stuff on that. Okay.
Networking for a second between those nodes? EMA or anything else? Like, how do you connect them?
Basically have this 200 gigabit connectivity between them. We don't have a lot of node-to-node communication, actually. We typically host all our workloads in a way that only one node is concerned with them. And so it's not a huge concern, basically. Does that help? Yeah. Mm-hmm. Okay, I mean, all of these GPUs consume a considerable amount of power, which is a good reason to have solar power, which we have in our office. If you tilt your head, you might be able to spot the smiley face even. Yeah, and an interesting, very interesting part of hosting these is, of course, software. Open source community is working on amazing software that can be used in on-prem deployments. We have been using text generation interface by Hugging Face and have now switched over to VLLM, all hosted in Kubernetes clusters. And also on the software side is basically the whole efforts in benchmarking. So we have our custom benchmarking pipeline in place, which is, for example, interesting, again, for our clients. Often German language capabilities are interesting, and these US or China made models need to be tested with regards to this. We also did some benchmarking before acquiring these AMD machines, which actually showed that inference latencies and throughputs are somewhat interesting. Okay, in closing, there's one advantage of having your own LLM-capable infrastructure I haven't told you about so far. It allows experimentation, right? And I brought 3 examples here. So as you might be aware, apart from text and code generation, there are also multimodal models, which can read images, generate images. There's something called OLM OCR, which is, again, an open weights model by the Allen Institute. It excels at OCR, but we have found in our application of it that it often omits or loses headers. So what we have here is like an invoice, and it just basically, as a content, extracts the main text of the invoice, but not headers and footers. And we've been able to fine-tune this model to not lose headers and footers, which was very interesting for our business case, because bank information might be in the footer, and we've put this on Hugging Face. We've also done research on how to influence the behavior of LLMs. So the idea was to selectively enable or disable the so-called experts in mixture of expert architectures, specifically DeepSeek R1. And it turns out it's possible to make such a net less self-censoring when asked about certain parts of history, for example. This is published on Archive, and this is one example that basically you need this infrastructure because otherwise it's just not possible for you to, well, fiddle around with all of the weights. And then the last example, also about fiddling around with weights, we have merged 2 models. Basically 2 DeepSeek models. One, V3, is fast. Another, R1, is great at reasoning. And our result is comparably good at reasoning, but faster in the sense of spending fewer tokens. And there has been some positive resonance on OpenRouter. Here's some usage statistics. Feel free to try it out. Here's the QR code to OpenRouter. And we also internally have seen this model excel at coding tasks like this test generation use case, for which the original R1 is just not fast enough because it always gets into these reasoning loops. So yeah, by the way, we also, so this is our internal chat interface. We also right now have something cooking. We are working on the world's largest open source model. It's a bit of a joke, but maybe. If you want to try it out, let me know. Just approach me. And yeah, it was a pleasure to be here. Any questions?
Thank you very much. Questions from the audience?
Where's that open source model?
It's on Hugging Face.
The biggest?
We're working on that. If you want access, you can talk to me, but it's not published yet.
Any other questions?
So what's the cost difference between running it yourself locally and using a service? Like what kind of throughput do you need for that to make sense?
Yeah, that's an amazing question. And probably from a purely financial perspective, none of this is worth it. Especially, I mean, our data center is located in Munich, Germany, which electricity costs are just not good. But yeah, for us, the driver behind this was being able to have this regulatory, data sovereignty thing, but then also kind of playing with stuff, the haptics. And that's what I meant with these kinds of experiments. You just don't do this when you just consume these models by, I don't know, the OpenAI API, but you really need to have these weights on your hard drives, basically, and being able to try out hybrid architectures and mixing model weights. So my non-answer is it probably is not worth it if you're just looking to save money, especially when electricity costs are as high as in Central Europe.
How much are they in Europe?
That's a great question.
They're 23 cents a kilowatt hour in California.
Yeah, I don't have this. Do you know this number by heart, Thomas?
That's such it. I think it's about the same.
In Cyprus, it's 35 cents of the euro per kilowatt hour, so probably somewhere along those lines in Germany, maybe a little bit cheaper.
In Cape Cod, it's 35 cents a kilowatt hour.
Yeah. So not globally competitive. Yeah.
40.
So something like 40, our research says. Not great. Yeah. Ouch. Yeah. Yeah.
Do you see some of those privacy concerns like being partially assuaged by these private cloud offerings that OpenAI is doing?
Yep.
Or is it hey, we want to meet some regulatory compliances, and so
Yep.
you have to do it on-prem?
Yeah, so great question. So you're asking about whether, for example, Azure, OpenAI endpoints address these concerns, and for some organizations they do. I mean, there was this kind of complexity I wanted to gloss over that. So basically, this legal risk of EU-based companies that they can never be 100% sure whether, US government, for example, could have access to data, even if it's partially stored or if it's completely stored in the EU. I think it's a complicated legal trade-off that every company does for themselves, but there are also groups of professions for which there are very special regulations, like lawyers, for example, or also from the medical field, where a solution like you mentioned might not be enough. But for many of our clients, it totally is, yeah. Okay, then thanks again, and I think it's time for lunch.
Yep, so lunch is in half an hour, so you have half an hour free. Yeah, lunch will be at 12 o'clock. So thank you, everybody. Thanks, Max.